Hello, and welcome to Interaction Design Modeling and Materials Module 1 Tutorial 2. In our last tutorial, we were introduced to Cinema 4D, the viewport, its UI, navigating around objects, and controlling the camera. Next, let's look at primitives and deformers. So, let's start right from the beginning. What is a primitive and what is a deformer? In Cinema 4D, a primitive is simple non-polygon geometry. There are a set of these simple shapes grouped together in their own tab that we're going to look at. You always start with some type of primitive geometry in Cinema 4D, but the workflows can change a lot. We will work through a different series of workflows in these tutorials, usually 1 or 2 per tutorial. 3D primitives are not polygonal objects. They are also called parametric because their coordinates, their corners, are just vectors. This way, they are also very small in the definition of a 3D model. They are just a few vectors in an XYZ grid. Some primitive shapes that you might recognize are cubes, pyramids, cylinders, spheres, and torus. What is a deformer? Deformers are like pre-designed tools that affect 3D objects in a set of predetermined but different ways. Some twist, some bend, some taper. Even with basic modeling skills, these deformers allow you to affect your objects, making them appear more complex. And because these deformers stack, it means that with just a few of them together on one object, you can create something very interesting in your designs. When you first add a primitive object to Cinema 4D, it's important to look at the Attributes tab to see how you can or cannot adjust it. For instance, if we look at a cube, we will see that it is a 6-sided object. And if we want to scale one side to make it a rectangle, you'll see that it's not always possible just the way it is. If we want to extrude it or divide it into segments, we first need to transform these objects into poly objects. Simple geometry, primitive, and parametric objects do not need to be changed into poly objects to be used in Cinema 4D or 3D design, but many things you're going to want to do may require them to be changed to poly objects. I know this may seem a bit confusing right now, but as we progress it will become clearer. Let's jump into Cinema 4D and take a look. Back in our Cinema 4D user interface, I'm going to switch to model mode, which will give me a little more of my viewport because I'm not going to be creating any animation today. Let's start by adding that cube that we talked about. When we look at our attributes, we can see that there's a size X, size Y, size Z, and in the segments, it's 1, 1, and 1. We can't select any one surface of our cube. Even if we go to the polygons selection, we can't select any because there are no polygons. Right now, the primitive object, even though we can move it in any of these one direction, we can't select any of the individual pieces to change them. We can't, for instance, grab this corner and move it, which is something that we're going to be able to do once we turn this into a poly object. That does not mean that we can't do interesting things with primitive objects. Some of the most simple primitive objects are splines. A spline in 3D modeling is a line. This line occupies space. We can select the line. We can adjust the line. But what this line actually is are just 2 points. A set of vectors on each end connected by a line. In Cinema 4D, there are a series of different splines. Some of them are shapes that we recognize. These can be used to build other objects. Similarly, the full primitive objects, such as the cylinder, the cube, the sphere, the torus, and so on, allow us to begin with objects that have a certain amount of three-dimensional consistency, but are actually just a series of vectors. Let's look at how we can use deformers next to make adjustments to our primitive objects. The cube always serves as a good example. It's an easy shape to see twisting and deforming. Our deformers are these purple icons. Let's start by adding a simple bend. If we go into our attributes, we can see that we can apparently affect the strength of the bend. But nothing happens. Nothing's going to happen because we need to add the bend to our cube. When I select the bend, I need to wait for the arrow to be pointing in the down direction. That tells me that it's going to be placed into the cube. And when I do, you can see that the cube itself now has some kind of a bend being applied. And if I adjust the strength of the bend, you can see that I can now adjust this cube. The bend deformer also shows the limitations of this primitive object. Other than the size that it's showing, we're still stuck with these segments. And these 1 by 1 by 1 segments means that no amount of bend is ever going to bend a one segment. Let's see what happens if we add more segments. So now, by adding 10 segments on this one direction, we can now see that the effect of the bend is fully realized. There are still angles, because even with 10, it's not smooth. We would have to add many, many more segments to make this rounded. And that all depends on what our purposes are. But the bend, as a deformer, has now made a much more complex object out of what is basically still a simple cube. And underneath this, if we were to remove this deformer, the cube is still exactly the way we left it. So the low polygonal primitive object is actually unchanged, and all of the deformers that are happening on top of it are just effects. So let's add a bend again. We're going to drop our bend into our cube. We're going to add some strength to it. Let's add a taper. In our cube object, if we are now to just add the taper directly onto the cube, we can see that we can taper one end. We can affect the curvature. What happens if we change the order? You can see that it completely changes the way that it's applied. It compounds. So if we now add a twist, we can have an extremely more complex object just from using some simple deformers. And by increasing our amount of segments, we can actually create very smooth, interesting objects. By changing the order of them. Also, you will find that most deformer attributes will have this interesting area of whether it's a limited mode, within the box mode, or an unlimited mode. This is referring to the bounding box. And you can actually see that each of them seems to occupy a fairly small area in relation to the primitive object. We could select any one of these objects and we could scale them up. And by scaling them up, they will start to affect the object on a larger or smaller way. If we only want to affect one small area of our object, it also depends on where in that object it is actually intersecting. If we affect it only within the box, it'll only affect the area in the box. A limited area of the object beyond the box, unlimited affects the entire object, regardless. When we look in our object manager and we see the cube and we have these 3 deformers, you'll notice that there is a hierarchy that has been created by dragging them and having them inside the cube. This makes the cube the parent object, and it makes the deformers children of the parent object. This is the language you will often use with Cinema 4D, where we talk about where in the file structure and this hierarchy of the file structure that the objects intersect and affect each other. And different methods of affecting the model are going to use different ways of addressing this. By now, we have added quite a few what would be considered pre-poly type effects to this. What do I mean? I mean, in our cube, now that we've added 20 by 20 by 20 segments, but we only see the effect of this. What if we want to actually see the lines? So if we go into display, we can now see the full effect of what polygons would look like. If we go back to our segments and we reduce them to their most simple 1 by 1, even cutting them in half, we can get a general sense of how much more complex this object is just by using these deformers. The more segments, the more smoother it appears. But remember that the more segments, the more complex the geometry. The overall size, when we're talking about millimeters, has no effect in digital file size. But the more polygons there are, the larger the file size. And the larger the file size of one object means that your scene or your environment will be longer to load, more data, harder for mobile to use. It's a constant battle with designing objects that are interesting and have low enough memory that they can load quickly and smoothly to create an interactive experience. We're always looking for the sweet spot that has the lowest poly count to achieve the desired 3D effect. Now, as you consider the types of physical objects that your Formstorming has been exploring, look at the deformers and primitives in Cinema 4D and explore the simplest ways to achieve these 3D effects. You should take 10 to 20 minutes to explore deformers and primitives before going to the next tutorial. In this tutorial, we covered what primitives and deformers are in Cinema 4D. We looked at how to create them and use them as we continue learning about 3D modeling. In our next tutorial, we will be jumping into modeling with points, splines, and surfaces.